Okay, so we're Team Newman. We've created the EcoMarker application, which is an environmental management system proposed by the E2 Management Corporation. Our main sponsor is Lynn Johansson, who's the president of that company, and our coach was Dr. Christian Newman, and I'm John O'Brien.
I'm Joe Dement.
I'm Ryan Switzer.
I'm Joe Gonzalez.
So a real quick overview on the domain itself. ISO 14001 is an environmental standard that is an international standard that's composed of a series of guidelines that set up an environmental management system for organizations that choose to adopt it. It's meant to be easy to understand and adopt, and allows for proactive and preventative ways to manage an organization's interactions with the environment. And this allows for systematic improvement of those interactions with the environment. Now, these might sound a little bit like buzzwords, but using ISO 14001 as a framework for an environmental management system can have real tangible benefits for your organization, such as reducing your energy consumption, allowing you to comply with legal obligations better, and causing less overall damage to the environment, which helps all of us.
So some of the main stakeholders for our project has been a group of companies known as the Collaboration. That's 16 companies from a variety of business sectors. We operated under the Chatham House rules, which is a set of rules that mean that sharing information is anonymous, so all the company names and information has been stripped out, and just the relevant environmental information has been given to us as part of the sample for our application. And some of the main industries that we are targeting for this application are steel, finance, mining, automotive, and energy. And we know that most of the companies are in the US and Canada right now that are adopting the standard, so we are looking to build a scalable application that will accommodate them. So the problem that ISO standard 14001, the 2015 revision, proposed a environmental management system that had some vague requirements for to evaluate and analyze these environmental opportunities. And the E2 Management Corporation came to us with the idea of making an application for that, and they wanted it to be a unified dashboard across desktop and mobile. They wanted there to be a map that you could view these eco-markers on, and they wanted you to be able to have pictures and allow that to better pinpoint what the actual problems were at a work site. And they wanted the application to be highly scalable, since there's going to be so many companies utilizing this application. A lot of the companies right now have unstandardized data in Excel files, and we're working to make them more standardized.
So our solution to this problem, as John just mentioned, is a web and mobile environmental management application. It's a lightweight app, so it can be used on as many devices as possible. It can be used by as many employees as possible. So users can quickly take their phone out and upload a new eco-marker into the system on site. It also lays out a standardized format for an eco-marker, which we hope will end up being a good start for any of the organizations that choose to adopt ISO 14001 going forward. And lastly, we also put in a permission system that allows multiple companies to have multiple different locations within the company, so they can track environmental risks on a location basis. And we also allow for different behaviors for different permissions groups, like managers versus just a shop floor worker. Ideally, companies will use this application to compile and log any environmental risks that they have, and this will allow them to evaluate and analyze these risks to improve their performance. It'll also allow them to spatially map the data, and they can view it on a heat map as well as other spatial analysis tools. And this will increase the visibility of the environmental risks within the organization. So by using our application, we hope that organizations will be able to directly improve their environmental performance.
So the way an environmental management system works is that a company may have any number of environmental opportunities that they may either have logged in CSV files or may just exist on the actual company site. With our application, any kind of employee who's part of that company can actually log these in their system, in our system, as eco-markers, and they can enter in different types of criteria for them so it can be mapped and better managed. Then the company can go through, compile all these eco-markers together, and then do analysis and evaluation on it so they can assess the impact that they were having on the environment. Then over time, they can actually improve their performance by resolving these different environmental opportunities and just diminishing their actual impact on the environment. An example of this in the real world is firefighters in Canada. So firefighters will often be dispatched to a fire out in the middle of the wilderness or wherever, and we'll oftentimes find that it's a chemical fire and they're not properly equipped to actually combat this fire. So firefighters can actually enter different types of chemical reservoirs, deposits, and so forth in this application. So when they're actually called out to the site for a particular fire, they can reference the application and say, oh, there's burning tires here. We can now be better equipped to actually deal with this fire now.
All right, so we're going to bring it over to demo. How do you move it forward? All right, there we go. So we're going to be doing a demo now. So I'm going to quickly mirror my display so I can actually see what I'm doing. Hopefully this works first try. Okay, keep. Okay, excellent. All right. So this is the EcoMarker application that we built. The first thing I'm going to be doing is I'm going to be showing you the account creation process. When you create a new account in this system, you have to enter an email address and a password. So let's just make an email address, test@test.com, and password. And this company field is the name of the company that you wish to join. As a user trying to join a company, you must enter the exact name of the company that you were trying to look into. If you enter a name that's not currently in the system, it'll ask you if you would like to create that new company. And when you create a new company, the user that you create becomes the admin of that location. But this company already exists in the account, so it'll tell me my account has been created. And now I'm going to quickly sign into the admin account for this company, which we pre-created with some data for the demo. So this is the admin account, and this is the main dashboard page. As you can see, we have some eco markers in the system already, which are easily divisible. So you see a image of the eco marker, you see the activity it corresponds to, the aspect, the impacts. This badge is for the type of category that the eco marker refers to, and this is the location that the eco marker is present in. You can see more information on the back of the card, such as the factors that came into creating the result for this eco marker. So the result field categorizes how much of a risk this eco marker is to the company and to the environment. So we have some fields that we multiply together to create this result field. So right now I'm going to approve that user account that I just added earlier. So the test@test.com. In the admin interface, you can approve the user. You can either make them an active user or you can make them an admin user. An admin user would be a company user. So we're going to approve them for the U of R location, and we're going to give them write access to that location. So we can approve that user, and then let's say we accidentally messed up that user. You could go to the manage user section, and you could change those permissions, or you could even edit their name, last name, or change their password if they have forgotten their password. Some of the other ways to view eco markers in the system are we have a tabular view where you can view the data in a table. You can select what fields you want visible in the table. So let's say I wanted to not have the duration and the detection visible. I could hide those views, or I could show all of the views. And that makes the table a little bit bigger, but now you can see it just like you could in their old system, which is Excel spreadsheets. You can view all the table, you can sort the table by different categories. You can sort it by severity, you can sort it by result, and such not. So now I'm going to show you the map section of the application. So you can view the eco markers on a map as well as on a thing. So this is the company admin. So you can see that they have access to both locations. There are some eco markers at RIT and there are some eco markers at U of R. We also allow you to view these eco markers in a heat map view, which allows you to better see what areas are of more impact than other areas. So the heat map is colored based on how many eco markers are close together, and also it takes into account the risk factor or the result factor for coloring the heat map. You can filter out parts of the heat map. You can filter on a text string, just looking for text in the data. You can filter on category, or you can filter on the location, such as RIT. So you can hide all of the U of R ones and just filter on the RIT ones if you wanted to, and whatnot. So now I'm going to create a new location into the system really quickly. I'm going to create an RIT2, and I'm going to create that account, and I'm going to add that user that I just created before. Wow, that went wrong. Oh, live demos. Why is that happening? Well, that's interesting. Well, that's new. That's never happened before. Okay. Live demos, though. Okay, so I'm going to import eco markers into the new location that I just created, the RIT2. And we're going to import them. You can import a CSV file, so I'm going to select this company B.csv file that I have. I'm going to submit it, and then on this page you're able to map the headers from the CSV file to our headers inside of the system. So in this case, I know the aspect number in this thing corresponds to our UID field, the activity corresponds to the activity, the aspect corresponds to the aspect, and so forth. And then, for the sake of this, I'm just going to map this field as the result, and you can submit that. It'll upload successfully, and then if you wait a second, it'll add the eco markers in. They come into the system with no pictures and whatnot, so you can edit them to have a picture field. So I can change the UID to be something a little shorter, so it looks a little bit better in our system. You can upload a picture. I use pictures of animals for this. You can geolocate. You can use your current location. And you can, if the geolocation is not correct, you can move the pin if you feel that it didn't get you in a good enough location. You can assign it a category from one of the categories we supply. And you could change the result from a custom result to a computer risk if you want to in the system. If you don't know what any of these fields mean, we supply tooltips for what those fields are in the system and what they are not. So let's quickly do this, just randomly. You can update that, and you can update the eco marker. If you changed your mind, you can edit it, and such not. Alright, so now I'm going to log in as another user account and show that some of the eco markers are hidden. So let me just see what another account name is. Did you make the password?
Yeah, 1, 2, 3, 4, 5, 6.
Okay. I'm going to use this account because the password is password for this one. So logging in as this user was added to just one location, so you can see that they only have access to the RIT location because they were only given permission to see the eco markers from that location. That's useful for companies where they don't want certain users to see all the eco markers from a location. But let's say this user wanted to export these eco markers from this location, so we provide a way for users to export it as a CSV file, and you can download the CSV file, and this is viewable in anything like Excel, and it'll export correctly out of the system. Alright, I think that's it for the demo. New? Create a new eco marker? Okay, yeah, we can create a new eco marker. I'll just demo one more thing, the process of creating a new eco marker, because I haven't done that yet. So you can create a new eco marker, you can give it any thing you want. You can pick a picture. If you're on mobile, it'll actually ask you if you would like to take the picture yourself. The app itself looks a little bit different on mobile. Let me just show that real quick. I don't actually have the cord to show it on my phone, but it is a progressive web app, so it does work perfectly well on a phone. So on mobile, the table, if you add a lot of fields to the table, it adds some horizontal scrolling, so you can actually see all the fields on the table. You can go back to the list view. We show it as a grid now instead of that. When you go to add things, we use the Material UI default adding feature. So you can add things like this, and if you were to use this on an actual phone, when you clicked this, it would open up the camera view. Alright, so I think that's it for our demo. Let's get back to the presentation, if I can do that. Maybe? Oh no. Oh, I tried. Oh, there's the presenter notes. There we go. All right. So now we're going to talk a little bit about how we built the application. So the architecture we chose to use for this application is we built a progressive web app, which is a web application that is able to work on all mobile platforms as well as desktop platforms. And we chose a microservices architecture because we need to meet the constraint of being able to run this application for potentially thousands of users. We need a more robust architecture. We use technologies like React and Redux for the front end. We used GraphQL for some of our backend microservices, and we used REST endpoints for some of our other backend services. All of our services are Docker containers, and we deploy them using Docker Swarm. We use a variety of databases that we will talk about in the next coming slides. But some of the justifications for why we used our front-end technologies is we used React because it was really easy to build a progressive web app using React, and React has a great developer community. So it was very easy to troubleshoot problems with React. We use Sass for all of our styling. We didn't actually end up using a CSS library. We ended up writing most of the CSS ourselves because we couldn't find a Material UI library that did all of the things we needed to do. such as having support for BOM navigation and the various drawers that open from different sides. So we chose to write our own CSS framework library type thing using Sass. We also chose to use GraphQL because it's able to scale a little bit better at a large scale. It's also really easy and to use on the front end, and you're able to choose the queries you want instead of having to make the endpoints that you want for your application. No.
More on the back-end side of things, we use Node for some of our services and we use Python for some of our other services. That wasn't intended. We actually had to rewrite some of our Python services as Node. The ones that use Python and GraphQL, the GraphQL library for Python did not have the features that we really wanted it to have. So we ended up going back and completely rewriting the ecomarker service in Node instead. But other than that, Flask served its purpose well for our other microservices like the image API or the file API. It was lightweight and easy to spin up a new service if we needed it. Because of our architecture, we were able to use the database technologies that fit the use case better. So we use Postgres for our user authentication system because user accounts and permissions are inherently relational data. So it would make sense to use something like Postgres for that. And for our ecomarker service, we use MongoDB for a few reasons. First, because it's schemaless. Earlier on in the project, we didn't really know what attributes needed to be on the ecomarker, so we wanted to be able to go through and change them. Ecomarkers are also 100% non-relational, so we don't need any support for relations within the database itself. And MongoDB also has built-in geospatial indexing, so we're able to just query for ecomarkers within like a map boundary. And Postgres does not have the ability to do that out of the box.
So yeah, the future plans that we have for your application basically include handing it off to the collaboration so they can deploy it on AWS themselves, and then they'll be handling any kind of future feature expansion from there, whether it be improving our exporting, better mapping, or supporting deleting of ecomarkers. This coming June, they're actually going to be presenting our application to an international community in Germany, which is going to be pretty awesome. And reflecting on everything, a lot of things went very, very well for us. We had very great communication with our sponsor. It was very osmotic, and we also chose a lot of great technologies that really helped us just get things going as soon as possible.
While we were able to choose technologies that let us get off the ground really quickly, that wasn't without its drawbacks, like I mentioned previously, with having to go back and totally rewrite a service. All this cutting edge technology doesn't necessarily have the support it needs for the context of our project. So that was one thing that we wish we knew at the beginning. Would have saved us a lot of time if we didn't have to rewrite basically the main domain portion of our project. And lastly, learning the ISO 14001 standard was also kind of a challenge. None of us really have any domain knowledge in environmental management systems, and on top of that, it was also a pretty dense document that we had to sit down and read through and really truly understand before we could get to work on this project.
All right, any questions?
What was the biggest challenge you faced in this project? Or top three, if you want to go that way too.
Biggest challenge.
We'll definitely start with the standard, just understanding the standard and what was actually being asked of us with the standard, because it was so dense and like a few hundred pages. So yeah, that was challenging. That would probably be like number one on my list. Anyhow.
I wouldn't say that was the biggest challenge. One of our bigger challenges, at least on the technical side of things, was our integration testing because of our architecture. Trying to test all those services together at once was a bit of a pain at times, especially during busier parts of the semester where the communication might not have been where it needed to be. So that was one thing that we definitely could have done a little bit better.
I don't know what the most difficult part was.
When did you discover the incompatibility of that Python library, and what kind of risk management did you put in place for that mitigation?
So I think that we discovered the problem with the Python library pretty early on, but we originally thought it wouldn't be that much of a problem, so we didn't really give much thought to it. But then as we kept working with the Python library, we realized that this problem was just compounding with more problems. And then second semester rolled around and we decided that it would be better for the entire project if we just rewrote that one service.
And do you have a sense for how, what was the impact of having made that decision?
Yeah, we lost like a decent amount of time with it, but on the other hand, what we got out of rewriting it was a better service. So I don't see that time as time wasted necessarily. I think it is time spent improving that specific part of the application. When we first noticed the problem, it probably would have been a good idea to note it down in a more formal way instead of just trying to hand-fist our way through it, because we knew it was an issue, and then we didn't really decide we need to rewrite until it was really on our way. And we kind of figured it would end up being on our way. We just didn't plan for that in the way we should have.
Right. Heard right, some of your backend were RESTful interface and others were not. How did you choose which approach to use? What guided that?
So a lot of the reasons that we chose to write some of the services as REST APIs is because we were using GraphQL for querying eco markers and whatnot, but GraphQL currently doesn't have a excellent way of handling file uploads and whatnot, and a lot of this application was uploading CSV files, downloading CSV files, uploading images, downloading images. So we decided to go with a RESTful API for those sorts of features, but then all of our bigger queries we chose to write in GraphQL endpoints, and that's how we sort of separated out which services were which services.
You mentioned that scalability was one of your key requirements. Did you do any sort of performance testing?
So we would have done performance testing. The real problem with performance testing in this application was we were given a VM for this class, and the VM itself would have been the bottleneck before any of the services would have been the bottleneck. So running performance testing would have been quite difficult for the application.
So I thought it was really great that you guys were able to use technologies that were more tailored to the actual use case. But I was more curious about, since you are passing this off to be maintained by another group of people, how proficient they are with those technologies and how easily maintained those are.
So we walked through with their developers on the deployment process and what technologies we were using, and they understood the technologies, and they said they were totally fine with our environment and how to deploy everything and how the technologies work together.
We had no hard technological requirements at the start, so we were kind of free to just run with whatever tech we wanted to use. If who we were handing it off to had a specific technology we wanted, we might have chosen that instead.
Thanks, 15.
Okay.
Probably fine.
Hello, everyone. We are the Wegmans team, and we are tasked with recreating the store reporting system. My name is Austin Gardner. We're here with Dan, Nick, Doug, and Brandon. Our coach is Professor Martinez, and many of our project sponsors from Wegmans are back there in the corner. So, as many of you know, Wegmans is a grocery chain based in the Rochester, New York, and Northeast region. If you walk into any Wegmans, you're immediately greeted into their prepared food section, which hosts all of their delicious subs, sushi, Chinese food, any of that kind of prepared foods. So when they first started creating that, the prepared food sections about 14 years ago, they tried to run it like how they do the grocery store. So they would look at 30-day snapshots. They quickly realized that this isn't really beneficial because the prepared food almost works like a restaurant. So you need, every single day, you need up-to-date information on how much food you have, what your labor is, packaging, etc. So they developed this system. As you can see, the user interface is a little old because it was developed 12 years ago, and the user experience is also pretty poor too. It actually takes 3 clicks just to get to this is the main screen for your store. And it's pretty hard to tell everything, what's going on. You're also able to dive in and kind of see more details about that. But then again, it does take those many clicks. So, some of the features of the old system are you're able to display a summary with the financial state of each department for a specific store. You're able to dive in, like I was talking about, and see detailed transfers and vendor invoices for your prepared food sections. As I mentioned, there's a kind of a poor user experience and user interface with it. It's built using outdated technologies like an Informix database and classic ASP. And like I said, it was built 12 years ago, so it's difficult to maintain. So that's where we come in.
All right, so we had a variety of roles fulfilled by our sponsors. We had project managers. We had the original developer of the original StorePro system. We had the team taking it over, and then a variety of end users. So as far as eliciting requirements from those end users, first we went to Denny, who is a chef who talked to a bunch of other users of the system and gave us feedback on how it could be improved. Second, we met Brad at the Pittsford Wegmans and watched him use the system and gathered requirements from that. And third, after we had developed a lot of the system, we talked to Ryan and got feedback on what we had implemented. So we also went and talked to Wegmans IT upper management, where we talked to the vice president of IT, we talked to the team that's taking it over, and we talked to some of the relevant business units. And with them, we validated that the requirements we had were within scope. So the purpose of the StorePro system is to empower chefs to make important business decisions within a couple minutes at the beginning of their day. So to do that, we defined a set of key features that we would like to expand upon the original system with. So that is in addition to all the features of the original system. So, for example, we have alerting capabilities, which are like performance notifications, enhanced data visualization through like charts and graphs, the ability to search through items, transfers, purchases, the ability to compare the performance of multiple stores together. And we were originally going to store a year's worth of data, but the business unit told us they only wanted the chefs to see a month's worth of data. So we extended it from 7 days to that month. So there is a slight improvement on that.
So now we kind of get into the meat of our product. So this is our technology stack. We were given a lot of requirements for our technology stack from our sponsors. It's like working with Microsoft Azure using Bootstrap as our CSS framework, and our backend framework using Microsoft's ASP.NET Web API 2. But they gave us some leeway with what we could use for the front end. And to come up with our technology for the front end, we were really deciding between React and Angular to use. So Doug and I went home having no front-end experience and did the tutorials for both React and Angular. and we both came to the decision that React is both easier to learn and easier to understand, and quicker to pick up. So at that presentation that Doug mentioned earlier, we had to defend our tech stack as well as defend our requirements. And so after a little bit, they gave us the go-ahead to use with React. We're also using Chart.js to use for our data visualization. So in the Microsoft Azure environment, Wegmans kindly gave us a little playground of $150 a month to develop our application. So our entire application is contained within a resource group that houses our web app, our database, and our application insights, with the only exception being Azure Active Directory, which is outside of our resource group. So the SQL database obviously holds all of our data, but with application insights, that monitors and reports on the status of our system. So times for HTTP requests and database query times. Azure Active Directory handles all of our authentication and authorization. So that takes care of all of that, kind of the pain of creating users and allowing people into our system. So with the Microsoft Azure, we also need to deploy into the Wegmans environment, because this is outside of their environment. So we're using the Azure Resource Manager to make a blueprint of our system as it is right now, and create a process to deploy it actually in their internal system.
All right, so now for the demo. I just wanted to give you guys one more look at the old system before we switch over to what we're presenting. We're pretty excited about it. So, like Nick just mentioned, we're using Active Directory to sign in. I'm not going to do it right now because I would have to get a text because we're not on a whitelisted Wegmans IP, and it's just going to take a long time. So, this is our new product. So, obviously, there's a lot going on here, but I'm going to kind of go through it as an actual user. So, I'm a chef. I'm the manager of a prepared foods department at a Wegmans. So, I am at fake store number 25. Normally this would say all of the real store names, but we can't do that for this demonstration. And currently we do not have data for today. So this is all live data, and right now it's getting pushed about every week. And on the live system, it's going to be pushed every single day, really early in the morning. That's just not something that we have set up currently. First thing you're going to see here is all these cards, right? Each of these cards, besides alerts, is one of the rows from that previous system that you saw. So there was a sales row, there was a food cost row, and we kind of exploded those out and given a lot more visual indication of what you're looking at. So obviously the second thing you're going to see is all of these colors. So Denny, who was our original end user, he said he really wanted these alerts. He wants to be able to come to this page, and just like the business unit, they only want him to be spending 5 to 15 minutes a day on this page. He gets to work, he checks what did we sell yesterday, what food do I need, and what do I have left, and what do I need to order. So he comes to this page now, and instead of seeing that chart, he can see, okay, hey, month to date in the top left, I have more than $200,000 this month. I'm doing great, so I don't need to worry about that. Whereas he sees the red in food cost and the yellow, the warning, and says, okay, I need to maybe cut back on all the stuff that I'm buying because I'm already doing more than I should be this month, and my week to date is getting there. So making those alerts is really, really easy. You go up to your alert settings here. You've got all the ones that exist, and we're going to add an alert. Oops. So down here you can see we have a preview. So we are going to do let's do a red one, and it's going to be if I'm spending more than $3,000 every week on labor, then I want to know about that. So we save it, we go back to the dashboard, and right here you can see, oh, I am spending more than $3,000 a week on labor, and next time you come to this page, if you were less yesterday and now you're more today, you're going to know that right away. So as far as the data visualization goes, this is really great, but let's say for shrink, you don't really care about what the exact number is, you just kind of need an overview. Well, for that, you can flip the card over. This over here will flip all of our cards except alerts.
and you've got your graph view. If I were to refresh the page right now, it keeps you on your graph view, and next time you come back, every time you come back, based on what computer you're using, you are going to see that graph every single time. So this is the total. If we hop over to here, this is now the known shrink, and it'll remember that. So if you want a graph, every time you come back, it's got to be a graph. So once you get your overview here, the next thing you're going to want to do is start diving into sales. So you go into your sales and you're like, hey, what did I sell yesterday, right? So we're going to check out pizza, a subcategory of pizza, and which one sold the most? Okay, so our dough balls sold the most. That's great. As you can see, I just filtered that. All you got to do is click right here. And if I already knew, say I wanted all their traditionals, I could just type that, and it's going to filter your table for you. So you've checked out your sales now, and you want to know food costs, right? So I know that I got some croissants yesterday. I can't remember how many, and I can't remember which transfer that was in, right? So you go to your counter-to-counter. That call, by the way, now that we're on live data, that was about 25 million rows in our database that it just went through. So you go to your counter-to-counter, your transfers in, and you're like, man, where are those croissants? If you were in the old system, this is the exact flow. You would have clicked food cost, counter-to-counter, transfers in, and then you would look through this, and I don't see croissants in there, that doesn't seem right. You go back, you pick another one, yeah, they're not in here either. Now, the flow is you start here, you open up your food costs, type in croissants, and look at that. It was counter-to-counter, transfers 56. This is everything else that was also in that transfer. So we have one more big feature we want to show you guys. We were really proud of this one, so it's the benchmark view. One of the things that the end users really wanted is they say, hey, I run the pizza department at store 25, like I'm at, and I want to know how I'm doing compared to stores 10 and 22, right? They're pretty similar size. I know they sell about the same, so I want to be able to compare myself. So here's big store 10. We're gonna 10. We're gonna add in 25, and we are going to add in let's see, 22. We'll do that. So this is all your sales right here. You can see exactly, as store 25, we are purple, and we are doing pretty well on sales. We're doing a lot better than blue on most days. They beat us a couple of the days, but I know that overall I'm doing pretty well compared to a similar size store, which means that I'm doing well for my store. Now the other thing you're going to want to check is your food costs, right? Because you can sell a lot, but if you're spending a ton of money on food, that's not going to be profitable. So you check out food costs. We're still purple here. We can see that we were beating the food cost for blue, and that we're spending about the same amount as them. So if we're spending the same and we're making more, then obviously I'm doing a good job. And if I was the number 10 manager, I would look at this chart and say, hey, what are some things that I can change to be more like store 25 and make sure that I'm contributing to my store? So overall, we really think that we did exactly what our customer wanted. They wanted this to be a lot faster. As soon as you come to the page, you have all the data you need, and you can now search things. You can just basically make the entire process a lot more simple.
Okay. Now, with any project, things are going to go well, things are not going to go so well. Things that went great for us, communication. Communication was really a key aspect in this project. We used Slack to communicate with each other, in which somebody was almost always available to answer any questions that somebody might have. Also, the Wegmans team was very good at getting back to us. We'd shoot them an email, excuse me, and within a day, we'd usually have an answer. So any important decisions that we needed to make or any questions we had that might, be impacting the current sprint were answered quickly, so we were able to, keep moving, keep our sprint velocity up. Speaking of sprint velocity, we decided a little ways into the project to switch to full stack. Reason being, at the beginning, we were doing feature teams. As we chose FDD as our methodology, this is what that methodology called for. That was feature team development. This proved to be kind of a bottleneck in our development process as schedule conflicts, time conflicts, all this stuff occurred. we'd find ourselves waiting on our partner to make a pull request. So we switched to full stack, and our sprint velocity went up, and as a result, we were able to accomplish all of our stretch goals. These stretch goals included, as Brandon showed you, the alerting. It included the searching ability, so it greatly speeds up the time that people are on this. It includes the benchmarking. That wasn't part of the old system as well. So all these things were able to be accomplished due to our switch to full stack development. Now, some of the things that did not go so well. The way that we assigned some of the stories and some of the sprint tasks, they were named a little poorly. So, for example, the sales details card. That was one. That would be one story, and it didn't really describe exactly what was going on with the story, and it was pretty broad as well. As you see, too many features in sprints was another one of our drawbacks. So, for example, on the sales card, you saw like a week to date, a month to date, last four. Each one of those should have been its own story. The way that we had it was all in one. So that kind of held us up a little bit, which also led to a sprint disruption index of 2. This sprint disruption index essentially says how many tasks each sprint did we have to push off. So we averaged 2 is what our average was. And integrating live data late in the project. As Brandon touched on a little bit, there's 25 million rows of data in some tables. There's 45 million rows of data total. When we were testing, we had about 1 million. So there was a significant difference in a little bit of the performance, so we had to go through and mitigate those issues once live data started flowing. For the future, next week we have a Wegmans corporate presentation, which we're going to be showing them. This is what we did, and these are all the goals that we met for you. They're going to be releasing it to users within 6 to 8 months. In that time, their team's going to go through the product thoroughly, make sure that all the calculations are correct, so that when they release it out, they don't have any issues there. They're going to put their own branding on it. Right now, it's, as you saw, it was a little plain as far as colors went. That was on purpose. This way, they can kind of put the styling to it like a lot of their other apps have, so they can get a similar look and feel. And finally, the end user documentation. Now, this is going to be what Wegmans' team does to kind of make a document so they can teach people how to use the system. And the reason we left this to the Wegmans team is because they have a certain styling that they use for all their documentation, so we figured it would be best left to them to come up with this documentation.
So before we break for any questions, we really just wanted to thank our coach, Professor Martinez, as well as our project sponsors for Wegmans. With their coaching and mentoring, I think we were able to really present and deliver a really cool product that will be actually used within the Wegmans ecosystem. So at this time, are there any questions?
If I understand this correctly, these are largely food input costs. Was there any consideration for looking at the output costs if food is not delivered as a product sold when you have waste? And I could see that from a life cycle perspective, a little thinking this could actually give Wegmans another level of opportunity.
Yeah,
So the shrink is exactly that. So your known shrink is, hey, we overfilled this container every day, and we know that, hey, we're using too much of this thing. Your total shrink can help you get your unknown, which is your total minus your known, and that's like, that could be theft, that could be misplacement of items and they go bad. That's this category right here, the shrink.
Does that include waste management disposal costs?
I do not know the answer to that.
Any other questions?
All right, let's thank the team.
Good evening. I'm Zach. This is Dave, Alec, and Noah, and along with our sponsor, Clark, and the RIT ECTET crew, and our coach, Rick, we are the Cellular Metrics team. So we've got about 20 minutes of pure octane for you, so let's get right into it. Right. Next. All right, so the problem when we started the project. So telecoms, they make a lot of claims, right? And the claim we're specifically interested in is service strength, location. I mean, I'm sure you've all seen the coverage maps. These are things that Verizon, AT&T, big companies like that, they make these to kind of help you along with, you know, where you're going in terms of I want this service or that service. But really, how can we be sure they're accurate? These are produced and operated pretty much entirely by the telecom companies. So the problem that the previous team and then the problem we inherited at the start of our project was how do we make an independent verification of the claims these ISPs are making? So how can we be sure not only accuracy in terms of cell strength of the location, but realistic things like data throughput on an actual device and other things such as that. Aside from that, we also had this net neutrality angle with internet fast lanes. I'm sure you're all aware this is a contentious topic, but what we were really looking into was what kind of impacts are these going to have on consumers from a telecommunications and a cell phone centric perspective. Is this kind of thing already happening today? Are there ways to kind of detect it or mitigate it or whatever? And, you know, things along that nature. So as the project progressed, we kind of shifted focus to another problem, and really the core of this is first responders and telecommunications companies don't really have a great relationship right now. So first responders have a difficult time of actually determining tower status. Of course, cellular network connectivity is very important when it comes to a disaster scenario. Everyone's going to be on their phone. They're going to be texting, calling, all that kind of thing. And first responders who are in this area are also going to be utilizing their phones to, you know, better what they're doing there. So without a direct line to actually see tower status, they're unable to determine a lot about the area, right? The people in it aren't able to communicate out to them. They're not able to safely go in and say, I'm going to have cell coverage. So what we were looking to do here, as well as the restoration strategies. So there's a lot of other areas that first responders actually need realistic cell coverage to do. And towers are pretty vulnerable in a hurricane, a tornado, a fire, a flood situation. Towers, you know, they might not survive nature's wrath. So this is kind of what we've drawn from this. First and foremost, we had an application that was already deployed on the Google Play Store. So our biggest priority in terms of requirements and sponsor needs was making sure that the application that was already out there was adequately supported, that maintenance was done on it, and that any big issues that the average user ran into during this time were things that we were addressing. They were part of our process. Aside from that, connectivity check, which is a big area in the first responder domain. Basically, this allows our application to kind of, you know, ping at people and say, are you there? Is anyone there in this area? There were a lot of people here, you know, 20 minutes ago before the storm rolled through. There's no one there now. You know, what kind of conclusions can we draw from that? Aside from that, we also have our Incident Commander portal, which is a web portal for our actual incident commanders to kind of operate this network. They can raise alerts, phone connectivity checks, they can place area things. These are all things we'll see in a little bit in our demo. And finally, data anonymity, of course. This is a pretty contentious topic as well, with all the data privacy leaks we've seen, data for sale and all that kind of thing. So a big step we were trying to take and a big focus that we had was making sure that the data we collected and the way we processed and handled it would allow us to get complete anonymous data from all of our users. So we didn't really have a concern of leaks or potential conflicts of interest in what we were doing. So now we're going to go to Noah for some of our system description stuff.
So here we have our system diagram. We have the heart of our system, which is the Android application. We have a bandwidth server, which will help us better collect data on the quality of your cell signal, as well as the coverage of your cellular device. This data is uploaded to the Flash server, which is then stored into our Postgres database. This database allows us to serve coverage map data to the Android application, so each user can see the coverage data for Verizon or Sprint or whichever carrier that you've selected in our Android application. The new portion of our system is the Incident Commander portal. The Incident Commander, in a case of disaster, can log into this portal through the Django front end and then mark an area for a tornado or whatever the natural disaster may be. That area will then will activate all the phones in the area so the first responders can get more accurate information on what's going on, who has cell coverage, where do we need to deploy an LTE truck or whatever to give these people coverage so they can call for help if they need it. Our design decisions, initially this was handed off to us from last year, so the Flash server, the initial Flash server, the Android application, and the database are things we maintained and iterated upon. The Incident Commander portal, we chose Django because we were already using Python, so we wanted to stay in the same language vein. The requirement was introduced a little bit later on, so we wanted to use something familiar with and has important things to help us jumpstart the development of our portal so we could get all the functionality our sponsor wanted. The Android application we had to rework because of the background execution limits that Android 8.0 introduced. So our application basically didn't work, so we had to rework how our data collection was scheduled in the background. And finally, our database, we needed to allow the Android users to download the coverage maps onto their phones faster because it just wasn't being fast enough. So we had to make changes to our database for the performance to be up to snuff. And next we have Alec, or Dave for the demo.
My name's Alec. So we're going to do a demo. We have a video demo that I did just the other day. So we have our two user-facing points of the system. We have the Android application, which we've gone over as purposes for doing upload and download tests, viewing the map data. Then we have our new portal here, which is responsible for Instant Commander. Right? Instant Commander, if you didn't pick up on it, their role is kind of overseeing the disaster scenario. They may say, oh, we're in this area, there was a natural disaster. We need to know where the coverage is, where it isn't, so that we can deploy our first responders correctly. The way it works is, and I'll demo that in just a minute, they will draw an area that they want, and any phone running this version of the app will go into a fast updating mode. So every minute they will run an upload and a download test, send those results back up, and the commander will be able to view that information live. There's also point alerts, which is a use case that a sponsor wanted as well. Basically a way for the commander to communicate a specific location where there's an issue, whether it's, I think we do in the demo like a downed power line or something that someone had to go address, for example. And the commander or the first responder on their phone would see the dot exactly where it is and be able to go exactly there. So without further ado, to the right, we'll watch this. So you'll see me logging into the portal right here. Simple Django front end. So we have a test alert, but so this is the dashboard view, which you see right here. We see all alerts. We can also see alerts I've created as this admin user. We have this nice simple map that will show any alerts that are currently active. That's a test alert, which we'll go into later. I'm going to go create alert in just a minute. And again, like I said, you can go to your own alerts, but here I will create alert. And do a point or an area alert here. I'm going to do an area alert first. Last week it was pretty windy in Rochester, so we'll do like a tornado simulation here. We'll say that we're going to zoom in on the map. A simple click on the map brings up this overlay, this tile overlay. can drag it, resize it to the area you'd like. And again, to reiterate, any phone that's now in this lat long box and within the time bound that I enter, they will be in a fast updating mode and we'll be receiving tests from them every minute. And that's of course configurable. So I'm adding some notes, high winds at RIT, power lines down, and so what else I'm typing? Loss of signal. And then I have the time, and you can get pretty exact with the time. You do date all the way up to the hour and minute. So, and obviously, an Instant Commander can go in here and edit and remove these as well. We've also added the Django admin panel where someone can log in as an admin and manually edit the entries here. So I'm going to go ahead and issue the alert. Then once you create the alert, it brings you to the alert page. There's two map views. One is a general view where you can get a reference point of where you are on the map. The sponsor asked for this specifically. The other one's a static view where the data will be updated. Obviously, I created this alert live, so there's no new data, but if we stay there for a while, maybe 5-10 minutes, you'd see new data points of active users. So that's it for area alerts. I can go out and again, here's the tab showing my alerts. Obviously, I'm the only one logged in, so we didn't have any other ones. I'll create a point alert now. And we'll show you on the phone side what this will look like as well. So zooming in, we're going to put it up on RIT. We're going to simulate like a power line is down, for example. Add some notes about it. It's the same kind of step as the area, except for this time it's a point. The category, we have a few simple categories, which you'll see the drop down in a minute that the sponsor wanted. We'll put this down as a tornado category, but easily added by any new developers picking up this project. This was a feature that was introduced pretty late in the term, say midway through the term. So it's pretty minimal at this point. But we'll say tornado category, and that's just the only thing that reflects is in the app it'll be a different icon for the end user. So brings me to the alert page. So let's go back to the dashboard. We'll look at the test alert that we created. Now this was an alert that I did the time bound from the start of the academic year to now. That's why this query might take a minute because it's going through a decent amount of data. But this will allow for a lot of data to actually be on the map, which you'll be able to see here in just a sec. Not too long, hopefully. There it is. All right, so you'll see the heat map render the values. So obviously this isn't indicative of an actual disaster scenario, and we don't have that many records, but that's what it would look like. You'd ideally, a commander would say, oh, there's no data here, and this is a very populated area. This is probably where we need to send first responders, or we need to put up a mobile network. You can also go to a satellite view, just so they can understand the terrain. Obviously, if it's in the middle of nowhere, and there's no coverage, it's not really much use. And that's about it for the portal endpoint, so we'll jump over to the app. This is the first view of the app. It's the download or upload and download page. I can go ahead and run a test. We have a hamburger menu to navigate the app. I will go ahead and run a test. This is just on an Android emulator, but it's exactly the same on your phone. It runs on version Android 6.0 and up, everything live. 8.0 and plus now. So it's running a download test right now. The buttons are in a cooldown mode. After 10 or 15 seconds, they'll come off. It's a security mechanism that our sponsor asked for, so people didn't just spam the button and take down our server. This is currently just hosted on a local server on campus. So this is done. We can, on the top right, I'll click a little icon here. This will bring up our bandwidth log and show us all the data we've uploaded and downloaded. Useful more for the developers, but the average consumer can look at this as well. Now we'll go to some different views. We're going to go down to the settings. Or actually, first we're going to go to the records, my records. So I can click my records. I can look at them and compare them to other carriers in my area. So you get a vibe of how good my cell coverage is versus another person. And then we'll go down to the settings here. Now there's a lot of settings configurable for the user. Importantly, they can only do things over Wi-Fi if they'd like, if they're worried about their data. They can also limit how fast the tests run and the size of the tests. Obviously, if you're worried about your data going over your limits, these are configurable for you. So here I think I'm changing the frequency to every 1,000 minutes or something. But yeah, you get the idea. There's some developer options at the bottom for the heat map, the radius and opacity settings for the Google heat map, which you'll see in just a minute. There's an about page, which not too interesting. Notes about the version that you currently have, as well as some more developer tools at the bottom. Now we'll go to our final delivery to the customer, which was this new, or our sponsor, which is this new map view. We have much more filtering settings than the last team. They had the filtering option on carrier, but now we've added this filter option on connectivity versus bandwidth. So here on the current view is bandwidth. There's also connectivity, which is a simple binary yes or no. Do we have coverage in this area during the time bound that we have set? And here I'm cycling through some of the carriers, so you'll see the different values. If you click on a box, on tile, it'll tell you the average bandwidth for that location. Which will show. The color scheme is red to green, red's low, green's high, so yeah. Click a green one there, I think it's 30 something megabit per second. You can also filter by time. And that's about it. And now when I zoom, now this is where the app and the web portal kind of connect. We can see that new alert, the point alert that we created. If we zoom in on it, we'll see that that is the point alert that we created, and I'll verify that. And passively behind the scenes, because this phone is emulated in Rochester, is actually behind the scenes running a test every minute and uploading them. There's not an easy way to show that, but it is in the area zone, so it will be uploading. But as you can see, I went to the alert. The additional notes is displayed on the icon over the map. And that's about it for the demo. So walk through the app. We didn't show the heat map just because we haven't exactly mastered our layout, our heat map for that. It looks a little inaccurate. We need to mess with the opacity and radius settings a little bit more to get something the customer might be actually happy with. We have some prototypes out, but we're still waiting to get those reviewed by our customer or by our sponsor. So that's about it for the demo. So this was a continuation project, so we'll go over exactly what we did compared to the last team. So we were handed a lot. Probably most importantly is we fixed a lot of bugs. This thing that we got handed didn't work, and through every sprint there was something new that came up. Even yesterday we fixed a new bug that a user found. And luckily, because we have this deployed on the Google Play Store, we get the updates on there in the debug output when their phone crashes. So it's pretty easy for us to find new bugs and fix them quickly. The Instant Commander portal is new, and along with its integration. The live view feature, which we demoed in the midterm presentation, which is that binary yes or no, do we have coverage in this area over this time bound. We expanded the filtering options like I went through. Data visualization improvements, the heat map, as well as the color scheme for their tile overlay. We've changed that to make more sense. We also created a method for the sponsor to receive daily statistics about the system performance in our server. So Noah created some scripts that run every day and update an Excel sheet on our Google Drive, and he can easily look at graphs and such. This was a big requirement for him because he wants to know when do we need to scale this thing. We have, I think, a little over 100 daily users of the app, so it's important information for him. Here's some more things. We improved the data aggregation scripts, so those overlays, there's some pre-processing that goes on there, and we had to improve the speed of those. Some database optimizations. We upgraded for Android 8.0, added some unit testing that wasn't there before, and the big sponsor requirement was that the data that Zach was talking about, we encrypt any transmitting data, so further lessen the worry of people stealing your data. And now Alex is going to talk about challenges.
So with any project, there's always the challenges. Some of the ones that we dealt with over the course of these 2 semesters was our sponsor frequently traveled to different conventions where he would talk with other people in the industry, show off our app, and come back with great feedback. That and posed a few challenges such as harsh deadlines. There were features that he wanted to have done in order to show off at his conferences, and that also changed with kind of like changing requirements as he would come back with feedback. The path that we were going would slightly change based on that feedback, and that was used to adjust our sprint length. We also had a little bit of a lack of clear development path early on. Part of that was due to the fact, like Dave mentioned, we began with a lot of issues with the app that needed to be addressed. So we had to deal with getting the app and everything in working order before we could kind of move on to new things. And then so some of the design decisions and other decisions that were made by the previous team weren't necessarily things that we agreed with. So that kind of was challenged us to continue going in that direction. With our reflection, there were things that went very well. One was that at the beginning of the project, we were all kind of working into features like, oh, this person will work on this person will work on this. As we progressed, we kind of each went in like our own area. So some people would work on things that they were more comfortable with or more familiar with. Like some people would work on like our metrics of metrics in the backend server. Other people would work on the app side of things. Other people would work on the web side of things. And I feel like we did very well communicating as eventually a lot of our things tied together. So I feel like we worked well together handling that. Things we could have improved has to deal with documenting our requirements. A lot of times we found ourselves going back through meeting notes and going back through our itineraries to find out like some of the specific details on what our sponsor wanted. And some of the lessons we learned just how important the domain knowledge is, and we learned a lot of that domain knowledge, and also like we should have been better with our requirements gathering throughout. We also noticed how much our sponsor appreciated our quick feedback. He'd email us with issues or questions, and often we could get back to them and have a full conversation on the same day. That was something that went well. We have a bunch of future goals for the project. One would be to improve the security. Technically, all of our endpoints are open right now, but we'd like to improve that so that way only users using the app could access those, and same for the web portal. We would also like to improve like what can be viewed in the web portal. Currently, like you saw there, any user can view all of them as well as just theirs. So we want to limit that. The Commander portal, as we mentioned, was added late into the project, and there's a lot of things that could be done with that, such as like a historical view or personalization, so that way like a user could like log in with a specific code provided and allow them to create an account that way. More alert options, which Dave mentioned, are fairly easy to add. We would like to see the Android app and the web portal kind of come together and kind of have the same features. As you saw, some of the web portal features have been brought over the Android app, but not like the heat map stuff isn't fully available on the web portal. That would be something that could be useful to someone who might not have a phone or might not have a phone that can access our app. So some of the data visualization stuff was mentioned. We would like to improve how the heat maps look, but then also improve the map interaction with Google Maps, so some of it isn't as nice as we would like. And then with statistics, we have a lot of data, but we only show some parts of it. I think it would be very, very nice if we could view more of that data, like, for example, like New York State average speed or something. And with that about wraps things up. If you would like, you can go to that URL there and download the app yourself and try it out. And does anyone have any questions? Yes?
Apart from this information, are there specific stakeholder groups or target markets that this app is intended for?
Yeah, so yeah, with the first responder end part of the app that we've talked about, all of our sponsors have been in contact and going to conferences with NIST. They're, after the hurricanes in September and everything, this has been a huge priority for them, and that's kind of the target that they're going for at this point. The end goal is they're actually looking for funding from NIST to further the project. Yeah.
You guys said that when you first took it on, you had quite a few issues that didn't work. Was there any documentation provided to you by the prior team with the listed, say, design decisions they made, reasons stuff didn't work, or any guidance?
Not as much design decision rationale. More, there was some GitHub wikis that explained some of the technical stuff, but I'd say it was pretty minimal. It was enough to get started and understand where to look. But in terms of like a bug list or something, it was there wasn't much, I'd say.
Okay, and did you guys have stuff kind of hands-on?
Yeah, that's been a big focus the last 2 weeks, is we've prepared a lot of documentation on new stuff we added and still outlining issues that we think should be addressed in the next team. Yeah. manner. You go first.
How's the battery drain when you have fast update mode?
Yeah, that's something recent that we've implemented, and we haven't really tested it fully. Don't have a clear answer on that, to be honest. We actually found a bug yesterday where if you updated the frequency of your test, it didn't do it so correctly from the last team. So the person said that it was draining their phone within a few hours, and that was updating even faster than a minute, I think. So pretty fast. But ideally, this is only for like first committers in the field to understand if they have coverage. So it wouldn't be as much as a daily user, just like, oh, I'm in a fast updating mode. This app that we've demoed isn't really for the everyday user.
So after the pivot for the goal of the project, it seems like it's mostly towards first responders. But that doesn't really seem to be that reflected in the app. That still seems to be mostly a hold from the first part. Is there some plan to kind of bring that more forward for the app users or something?
Yeah, I mean, the sponsor and the team behind kind of still want both ends. So they still want to have the user base to get the data. At the end of the day, they want the data. I think that's very important. But they've also pivoted and want, so they want both is the end answer. Yeah.
So when you trigger the rapid updates, if your user leaves the incident area, does their phone stop doing the fast update?
Yep.
Okay,
Exactly.
so real time is looking at whether
Yeah, yep.
they're in that area. Okay.
All right, let's thank you.
Thank you.
All right. Hello, everyone. We are the bike share team. We worked with student government to create a new bike share system, and this is our final senior project presentation. So the team, I'm Gareth, this is Tristan and Megan, and Kyle unfortunately couldn't make it today, and our coach Bobby also unfortunately couldn't make it today. Oh, and our sponsor was, of course, student government. To give you a little background, so the original bike share was created in 2014 by student government, and that included 20 bikes, which it was a manual locking system. So in order to go pick up a bike, you had to go all the way to Gleason, and you had to go to a desk and ask someone, "Can I get a bike?" And they would check you out and give you a lock or a key to a lock, and then you'd be able to take the bike wherever you want on campus. And then in order to return it, you had to bring it back to Gleason. So as you can imagine, this wasn't really useful for students, specifically upperclassmen that didn't live over in the dorms. So not a lot of people used the system. So for a solution, first they looked for third-party vendors that could solve their problem. So they were looking for an automated system in order to more or less make it pretty seamless for students that needed to get a bike. They could just walk up to a bike, unlock it, and then have a bike to use for as long as they needed, and then return it wherever they needed as well. So one of the providers that they went with is called Spin. You might have seen them around campus in the fall. They were the orange bikes that were pretty much littered across the entire campus. So obviously there were some issues with that. So one being a high cost. So they wanted quite a bit from student government just to get the system on campus. And then at the same time, they would also charge students. Student government wouldn't get any of that money. It would all go to Spin. So obviously it wasn't a very good solution for them. And of course it was a dockless system, which meant you could put the bike anywhere, which ended up with bikes in parking lots, ponds, dumpsters, you name it.
Okay, so one of the first things we did was figure out what the system actually had to do. So the main thing they wanted was an automated bike track. They wanted to have a mobile app that came to the new admin system, and they wanted it to have a better locking system so that you didn't need to go all the way across campus in order to get a key. What we end up delivering is a cross-platform rider application that runs on Android and iOS, and also a generic system that can easily be modified to support any type of internet-connected lock. We also have a fully featured admin application that student government and the Parking and Transportation Office can use to manage the data in the back end. And yes, so we have some maintenance tools in there for Parking and Transportation to maintain the bike and fix damage and get reports of damage and that type of stuff. So one of the big things that student government really wanted was they wanted a really nice locking system. They wanted the app to be able to lock and unlock the bikes, basically just like Spin did. It's a very, very high level, high priority requirement, but when we searched the market, we didn't really find anything that would solve the problem. We spent some time investigating Bluetooth locks, so the phone would connect to the Bluetooth lock and unlock it that way. Unfortunately, they were kind of a dead end. They didn't work all that well for sharing between users, and they would take really long to unlock and lock. Like sometimes it would take up to a minute after hitting a lock button for the lock to actually close, which you don't want to have people just standing around waiting for a minute when they need to get a class or something. So after talking to student government, we decided, okay, well what we can do is we can basically step out a lock, and we can design a system to work with that lock. So in the future, when they find an index-connected actual hardware lock, it's fairly easy for them to drop it into the system and have the system work like it was designed to.
Cool, so let's go over the technology that we used in all three of our deployed apps, our mobile application on iOS and Android, and our administrative application, as well as our rider application, or our backend service, sorry. So first, our front-end apps we're using this service called Expo, which lets you use front-end technologies to build, deploy, everything you would need to do for both iOS and Android.
This was great. At first, we thought we might have to eventually detach from Expo to have native bindings for both iOS and Android with our Bluetooth locking mechanism. But because we decided to go with a fully internet-connected lock, you can actually lock and unlock the bike using WebSockets. So this allowed us to keep our app on one build system, which is beneficial for student government and anyone maintaining the software, because React and Redux are technologies that students here are pretty good at picking up. And Expo has fairly little overhead to get deploying. The admin application uses similar technologies. We were looking for things that are easy to support and that students at RIT are really familiar with. React and Redux, we both have experience with them, but they also are really well suited here because the development for mobile and front end could actually use some shared code in certain areas about how we actually wanted to fetch information about bikes. And that made reusability really awesome. And React has a bunch of great UI libraries, React Semantic UI, which we use, that made all of our user interfaces really great and easy to work with. Some other libraries and APIs we used, I just mentioned React Semantic UI, along with the Google Maps API v3, let us have like really great drawing features on maps where you can place bike racks, which lets the administrative people easily update all of the maps without worrying about coordinates or anything like that.
Hey, so my favorite part of this entire project is back end. I may be biased because that's what I worked on, but so we made this using Python and Django, which is a requirement from student government. They really wanted something that would easily maintain by students, and Django is taught here at RIT, as I'm sure all of you know. So that was just a really great tool for us to use. We also got to use some really nifty technology, like a GPS-enabled database. For example, Spatial Light, or what we actually use in our development and testing environment, which is PostGIS. And this will allow us to do like spatial queries. So we can say, okay, give me all the bikes in this area. Or I want to check the bike in over here, is that allowed? That kind of thing. And then we also integrated serverless support, so you can actually log into the system with your RIT account. The original bike share did not have that. You had to make your own account, and that was not a very popular feature. You had to keep remaking the account like every year or so. So with this, we can pull it right from RIT's system. We can have, the data. We can know if they're a student. We can know if they're a faculty member. Right now, the system is only open to students, so I'm sorry, professors, but you have to walk.
Alright, so with that, we'll jump into a little demo. Let's see here. Alright, so we're going to start off on the mobile app. So I've already logged in with SHIB, but you just... So all you do is you just log in with your RIT credentials, and this will bring you to your main page here. So to start out, you can see we have a map view of all our available bike racks that we have, or you can call them check-in areas. They don't necessarily have to be bike racks. They're just locations that we allow the system to check in and check out bikes at. So you can see here currently, for test reasons, we have a location, check-in location all around Golisano. And then we also have a few bike racks around campus that have a few bikes at them. So I have a QR code up here. On all the bikes there will be QR code stickers. So all you have to do is you have to hit checkout. And you can see I have my camera open. Oh, see, it's pretty fast. So I accidentally scanned the QR code. But you can see here that when you do go to check out the bike, you can see that we provide some information about the checkout period. So the checkout period right now is set to be 24 hours. So after 24 hours, you'll be expected to return the bike. And as well, it provides some safety tips with a nice little illustration on how to wear a helmet. So when I say I'm ready to go, you can see I now have the checkout view ready. So we still have a map here of where I can check in my bike. And at the top, you can see I have a nice status bar showing me which bike ID I have checked out and the amount of time that I have had the bike checked out for. If you do exceed 24 hours, you'll see a little warning symbol in this status bar telling you that you need to return the bike.
and you'll also receive a notification on your phone that your 24 hours is up, and you'll receive penalties if you don't return the bike. You can also see here on this screen that there is a lock icon. So as Megan mentioned, we don't really have any hardware, so we did make a mock site to stand in for a lock. So bear with me, this is going to take a little bit of finagling because I have to get the lock ID and make sure this works. Alright, so I should be connected to the lock, so if I click unlock, you can see here that my phone starts saying it's unlocking and we're unlocked. And if I go over here on my phone and I press lock, same thing happens to my lock. So the lock would be able to unlock itself with, if you've used Spin before, they have a manual locking thing. So there'd be like a lever or a button on there. And that's how you unlock and lock. So when I'm done with riding my bike and I want to check in, I just hit return. It checks in the bike for a little bit, and then we're checked in and my bike's returned. And as you can see here, we get a nice little confirmation. And then if I'm all set with the bike and I don't see any damage on it, I can just click OK, looks good. But if I do see some damage, I can click here on report damage. And that's not supposed to happen. I love live demos. It should autofill, but we can just scan the QR code to see our bike ID here in the damage report screen. We have a few damage types we can choose from. So some of them are pre-filled that it'll mark the bike as critical, or the damage is critical and the bike is unrideable. Some of them are not like that, so like cosmetic changes, I can just say there's some scratches. So some scratches on the bike. And I can submit this and I get a nice little confirmation. And you can see my bike is still been returned and I'm back at the main screen. And if I want to go report another thing of damage, it's right there for me. Alright, so that's it for the mobile app. But now we have our fully featured admin application to look through. So to start out, we have a nice little status screen here for the home screen. So you can see a few simple stats here. So we have active rentals, total rentals. So that's the total rentals that have been processed through the system. Total riders, so that's the total riders registered for the bike share system. And we have total bikes, so that's the bikes available. We can go over here to our bike screen, and you can see we have markers for each individual bike on the bike, or in the system. And we can see where they are and what racks they're at. So, for example here, if I wanted to change the location of the bike, I can connect here and say I want to move this to Global Village. I just click on here, give it a few seconds, and there we go. It's popped, so bike 1 is now at Global Village. So that was kind of just a mock moving of the bike. So when we actually have locks on the bike and they're sending location data to the server, you'll be able to see these bike locations live updating in this view. And of course it has the general actions you'd expect, so we can create a bike here. These are available locks we can choose from, and we can choose whether or not we want the bike to be visible when we create it. So we've created it, and we can see down here that we have a new bike with no riders. We can easily generate a QR code that we want to stick on our bike so people can check it out. And with this, you just save the image and print it onto the bike. We can edit it. Not much to do here. And then we can also delete it if we don't want to have it in the system any longer. So on the lock page, you can see all the locks that we have in the system and which bike they are assigned to. You can see that we have quite a few excess locks, and we can just easily go down this list and delete a bunch of them. The one thing to note here is that we don't yet have a create or edit flow for locks, as we're not quite sure what that's going to look like with the hardware. So that's kind of something that's going to be up to student government to work with, either a student team that's in like electrical engineering or something like that, building lock for them, or something for them to implement when they find a third-party solution that'll work within the system. So that's why we don't have like edit or create here. Pretty similar story for bike rack view. So this is how we see and manage our check-in. So you'll notice it's very similar to the mobile app screen. And through this, we can choose which bike racks we want to see. So we can click on here and it'll bring us to the bike rack. We can also add a new bike rack. So say we want to add a Gleason Circle bike rack, since that's a pretty high traffic place. All we have to do is we have to draw a little polygon here, and that'll auto close for us, and we just select a marker, and we can click our marker. We can do Gleason Circle for our name, and then just some description. I can reset the drawing I made. I don't want to do that, so I'm going to submit, and that'll create the new bike rack for us. You can see over here we got our new bike rack, and there it is. So we can click on the map and it'll show us. We can also edit that bike rack. Say if we wanted to make the check-in area a lot bigger, we can do that pretty easily. And save, and you can see it's updated. Pretty simple stuff. And then we can delete it if we no longer want it, and it's gone. Same thing for users. So permission management, there's only really 3 scopes that we have in the system. Access to the system, which only students and any admins have. So that's your basic check-in, check-out, report damage. Admin access, which gives you access to everything in the system, and maintenance access, which I'll go over later what the maintenance flow is, but it will give you access to the maintenance flow. And here we can just list all of the users that we have available in the system, and we can do a search as well to easily find users as well. So the maintenance flow is another thing. So you can see the damage report that I did earlier. We can see the details, so we can locate the bike and the damage report, and we can also delete or acknowledge it. But I'm going to save the acknowledgement for the mobile app. So if you're enabled for maintenance mode, you can enable maintenance mode on the app, and you can see here that the map updates to show a list or a view of bikes that have damage reports on them. So in order to check that bike out, I'm going to scan the QR code, and I can see the open reports that I have on it. And I can either unlock or lock the bike, or I can acknowledge these reports. So if I acknowledge them, they change to acknowledge, and that means that the bike is no longer a part of the system and can't be checked out, and that I, as a maintenance person, am going to bring that to the workshop and fix up the bike. So in the system, you can see that these have changed to undergoing maintenance. I can see my details still. And say if I wanted to finish up the maintenance on this bike, I can easily say like all fixed, and that'll remove it from the maintenance flow, and I'm all set. Last thing we have to show is settings. So here we have a basic toggle for whether or not we want access to the bike share. So this is for if, or during the winter when we don't have bikes available, we can toggle that off, and you can see the message there saying that bike share is closed. So if we go back into bike share and relaunch the app, we can see that I didn't save. We can see that it doesn't work.
Use tab, so you can access it anyway.
Oh, yeah. So anyway, I'm in the wrong mode, that's why. There we go. So you can see that it doesn't allow checkout, and that we have an alert here saying that bike share is closed for the summer, for the winter. And that's the demo. So let's see. So upon reflection, so what's left? We really only have the lock hardware left, which is something that we really couldn't accomplish in the time frame allotted, especially since we're not hardware people. So we really needed a third party to come through on that, and we couldn't find one. So that's up to student government to implement when they can find that solution. Improving upon testing is a big one. So we didn't really have a lot of unit tests on our code, which makes kind of the transition over to student government as we hand off the code a little rocky, since they don't quite know what's going to break the system. So that's something we wish we could have spent more time on. Documentation is another big thing. So we need to write up
how to use the system for people that aren't quite as technically inclined. And of course, live testing. So since we didn't actually have any live lock hardware to use this on, it was kind of hard to do some actual live testing where people would actually be using the application. And a little reflection. So it was really great working with the student government. If you guys want to butt in at any time, let me know. But it was really great working with them. They had a lot of great feedback. And from Spin as well, learning from Spin as well, they gave us a lot of pointers on what we can make better from the system and what they didn't want from Spin. And we also gave them a lot of ideas, and they also gave us a lot of insight into those ideas and what would work and what wouldn't. So it was really great working with them. And I think our team worked really well together as well. It was very easy to kind of work off each other and manage workload. We both kind of had our own domains, myself working on the mobile app, Megan working on the back end, and Tristan working on the admin. So it was very easy to manage workload in that sense, since we all had our domains. Yeah, so any questions?
Is the student government then responsible for building the business case for this?
What do you mean by business case?
Well, how do you afford to provide bikes?
So they already have 20 bikes from the existing project. The only thing that they haven't acquired yet are the locking mechanisms, which they have a considerable budget for, which they told us. So they are absolutely comfortable with acquiring that.
Student government wants to pay to provide bike share for students. The only problem with the third-party solutions is that they want to charge directly per ride, which would be charging students.
When you're marking out like a new rack or something, I saw you draw a polygon first, and then you kind of point marker. What is the purpose of the polygon? What does that functionally do?
So, since the locks are internet connected, bikes can only be checked in certain locations. This is because, with Spin, people would drive out to the parking lot next to their car and leave a bike in the middle of the parking lot. So the idea here would be that you can actually limit and restrict the areas in which users can check in the bikes, which will be done through the GPS on the internet lock.
Got it. But I guess more specifically, if somebody draws a giant box, right, then that means you can check, you can drop the bike on the ground anywhere in that spot and it registers it in the right spot.
Yeah, we have a mode for that called Drop Anywhere that student government could enable if they want in the settings. But they typically, from seeing how Spin, all that went down, they decided to avoid that.
Okay.
I wanted to ask that question about, okay, so with Spin, there were bikes being left in the pond, for example. What does SG or bike share program plan to do with students that don't? What penalty would there be if there is no cost associated for students? What is the penalty if they're not expected to a designated location?
Yeah. So we definitely asked about this, and security was a major concern for us when building the system, which is primarily why we also decided not to go, or another reason why we decided not to go with Bluetooth locks. But when it comes to cost and penalizing students, since it is through RIT and your credentials, you're using your RIT credentials to log into the system, you're uniquely tied to that. So when you do check out a bike, your user ID is on it, your information's on it. There's not really any escaping that. So if it does end up in the pond and you're the last person that checked it out, they know who to go to. And that wasn't really in the scope for our project, automatically charging students and things like that. But that's definitely something that could be built on top of the system. Yes.
How did your methodology kind of help or hinder the requirements aspect of this project?
Yeah, so our methodology was Scrumban. You can check out our intern presentation if you want to learn a little bit more about how we implemented it. But more or less, that allowed us to not have a lot of the overhead that Scrum has, where you have to deliver on sprints and you have to do burn down charts and reflections and all that. So that allowed us to really move really quickly and also allow for student government to interject with any feedback or new requirements that they had while we were developing. which meant that not only were we able to move quickly and around our schedules as well, since we did have other things going on, but that also allowed us to kind of let the system morph around the new discoveries as we were making as building the bike share, or during building the bike share.
Yeah, we also had, our sponsors had access to our Trello and our Slack, so there's a bunch of asynchronous communication going on Slack where they were really quick to respond. And like, because the requirements, they wanted us to do a little bit of brainstorming about finding a good solution about the locking mechanism, so having that like direct communication with them was really helpful.
17.